Hi guys, welcome to my third episode of Love the Byte series. My name is Samuel Kamochu, telecoms and a software engineer for the last 13 years. I'm also the co-founder and the lead presenter at Meliora Technologies. In this episode, my objective is to help you appreciate why computers use binary number system. In the previous episodes, we've talked about host A being able to send a message to host B, the word hello. We also learned that each of the letters can actually be represented into a numeric format. And in this case, we use the ASCII code. We also learned how to convert those numbers into binary number system, convert them into hexadecimal number system. And yes, you must be familiar to do with that. In case you're not familiar with this information, you can go back and watch the previous episodes. Now, for us to understand why computers use binary, I'll just do a quick recap of just looking at one letter, 72, and its binary representation. So I'll just do the quick conversions like we did in episode 2. I'll take 72 divided by 2, gives us 36, remainder 0. You record the remainder. 36 divided by 2, 18, remainder 0. 18 divided by 2 gives us 9, remainder 0. 9 divided by 2 gives us 4, remainder 1. 4 divided by 2 gives us 2, remainder 0. 2 divided by 2 gives us 1, remainder 0. 1 divided by 2 gives us 0, remainder 1. So by now you know that 72 is the same as 1, 0, 0, 1, 000. So if we represent these as 8 binary digits, then we add a 0 to the left because it's not significant. Adding a 0 to the left of any number doesn't change the number. Now, for us to consider why computers use binary number system, let's look at transistors, which are the core of the computers. Transistor is basically a simple tiny switch that can either be on or off. It can be flipped on or off using a very weak electrical signal. So I have two images. The notation, the left is off and the second one is on. So in the event you want to send a number 72 or to store a number within the computer circuitry, then we need 8 transistors, and each of them will be represented as shown on the screen. The second one to the left is on, and the 5th transistor will also be set to on. That way you'll be able to represent 72 within the computer. I know some of you might have already noted that with 8 transistors, you can actually represent 256 possible values, with the smallest value being 0, with all the transistors off, and with the largest value being 255 when all the transistors are set on. Now, the other thing I would like us to look at is how computers send data over the wires or over the network. So we can look at host A, which has a physical communication device, and B, which has an equivalent communication device. You want to send 72. In binary format, you have 01001000, and you want to use 8 wires. So essentially what will happen is that the communication devices will power on the wires. Wire 2 will be on and wire 5 will be on. That way, within that clock cycle, you can actually send the number 72 from one device to the other. So I know some of you might be asking, why can't we use 2 wires, and instead of sending the zeros and ones, why can't we just send 72? The first wire sends 7 and the second wire sends 2. Basically, we use decimal number system as opposed to binary. Now, in binary, you just need 2 voltage levels. Let's say 0 is off and 5 volts is on. But in the event you decide to use decimal, you need 10 levels of voltages, meaning that you have to have a value representing 0 and the highest value representing 9. And sometimes this can be very difficult to stabilize with all these things we know about the voltage gain and the voltage drop within the computer circuitry. So you can read more about that. But in conclusion, all we can say is that in digital electronics and in communication, It's based on the design that every signal in a circuit is either in the state of on or off, or you have high voltage and low voltage, or sometimes you use true or false, or 1 or 0. The words binary basically means two states. Why is this important? I don't know, but I think this basically helps you appreciate how stuff works within the computer and makes you a better engineer. Secondly, you also have scenarios where, given a number, you might need to convert it back to binary format for you to be able to appreciate or to decode the information that is being sent. So in the case of diameter protocol, we have 8 binary digits that represent special flags that are very important to the receiving node. So the first bit represents the request. If it's on, it means it's a request. If it's off, it's an answer. Proxiable, the second bit or the second binary digit, when it is on, that message can be proxied. When it is 0, it cannot. And the third binary digit definitely represents error. When it is on, it's an error message, and when it is off, it means that there is no error. In case this sounds interesting to you, or you think this might be beneficial to someone else, please share and feel free to like, comment, and subscribe. Thank you very much, and see you again in the next episode.